Okay, I'm Timo Räsänen. I work at Nokia as a senior cloud engineer, and I'm based here in Finland. And my presentation is about data center automation and how we use NetBox as our source of truth for the infrastructure. So in this presentation, I'll tell you briefly what our team does and a bit of our infrastructure. And on the second part, I will cover a brief intro on the NetBox. And then I'll tell you a bit of our rack creation process, which means that how do we populate the data initially into NetBox. And that's basically the first step on our automation pipeline. So we have quite many automation cases which involve NetBox, but I selected this as an example because this is the initial step for how we populate data to NetBox and then introduce new hardware into our infrastructure. And I also have a short demo at the end of this presentation about the rack creation process. So our team NESC, or Nokia Engineering and Services Cloud, is Nokia's internal private offering, cloud offering. And we provide OpenStack, Kubernetes, storage, bare metal, databases as a service. And if I would need to describe our team in one sentence, I would say that we just provide cost-efficient computing resources for Nokia's internal use. We also have a hybrid cloud offering, which basically integrates our internal clouds to the public clouds. And our infrastructure in numbers, so we have 7 data centers across the globe, roughly 400 racks, 12,000 devices, including servers and switches, and 720K cores, and 50 petabytes of storage, and roughly 5,000 accounts. Okay, then a few slides about NetBox. So how many of you are familiar with NetBox? Okay, quite many. What about how many of you are running NetBox in the production? Okay, cool. Okay, but so I'll still have these couple of slides about NetBox and for those who are not familiar with the tool. So NetBox is a DCIM and IBM tool, and it was originally developed by DigitalOcean network team, and they open sourced it back in 2016, if I remember right. And the project is currently sponsored by a company called NetBox Labs, which also offer commercial support for the tool. The project is open source, and it can be found. The source code can be found from the GitHub. And NetBox is built with the Python, Django, Postgres, and Redis. So this is quite common stack for open source network automation front. NetBox has very active community and it's very actively developed, so there's a new release coming up almost every 2 to 3 weeks. NetBox has very nice GUI, but from my point of view, the best part of NetBox is the APIs, which allow very easy integration to with the other tools and other processes. NetBox can also be very easily customized in multiple ways and extended if, for example, certain data model or feature is not available on for your needs on the main release. And as I mentioned on the earlier slide, so NetBox is a DCM and IBM tool, and here are a couple of key features. So what you can document there. So you can document your sites, racks, devices, whether the devices are servers, switches, routers, PDUs, they can be modeled there. The connections between the devices like network, cabling, console, and power. Of course, the IBM section, you can document your IP addresses, networks, VLANs, VRFs, and also the virtualization. So your clusters and VMs can be documented there. Also the power. Data circuits, like your internet links, for example, could be documented there, and also provides config context so that you can add like configurational parameters to your devices. And I think the key feature comparing NetBox to other DCIM and IPAM tools is that these two parts, DCIM and IPAM, are tightly integrated. So what it means that you can, when you allocate an IP address, it means that you can assign it on the interface which belongs to your device. So if these two entities would be totally separated, you need to have some sort of way to integrate these tools together. And this is quite an important slide, so what NetBox is not. So usually when I talk about NetBox, there are some misconceptions on what NetBox actually does. And they might be originating from some other tools that does all of this. So NetBox is not a monitoring tool. There's no automation out of the box. It's not the DNS or DHCP server, and it's not a tool for configuration management. But so NetBox should be considered as a source of truth, and it can be used for all of these cases. So, for example, you can use NetBox inventory for your monitoring tool, or you can generate DNS and DHCP entries from the data in NetBox, and you can also, for example, generate configuration based on the data in NetBox. Then a slide about the hosting options. So there are many ways to run NetBox. So there are instructions for running for manual installation on the NetBox documentation page. There's an Ansible role. There's a Docker and Docker Compose, which is especially handy for development purposes. And then there's a Helm chart for running NetBox on top of Kubernetes, and this is the way we actually run it. And then there's the commercial offering, the NetBox Cloud, which is provided by the NetBox Labs. And this one has like SLAs and official support. And we have been using NetBox at NESC since 2017, and we use pretty much all the features NetBox has to offer. And we have various integrations from NetBox, so we generate DNS entries, we generate DHCP configuration, we use dynamic inventories, for example, for Ansible and our monitoring solution. We enrich log events based on NetBox data and, for example, generate configuration files for devices. And then a few slides about our rack creation process, so basically how we populate the data to NetBox. So our infrastructure is rather large, so the automation is a must, and also having a properly designed source of truth, that's also a must. So it means that we need to first populate the data into NetBox before we actually deploy anything into production. And for example, adding a new rack is quite a common operation in our use case, but basically this could be anything else, any devices that you might have. So in a case where we add a new rack, we of course need to document the rack to the NetBox. We need to create the devices, and we need to create the cabling into the NetBox, and also assign some IP addresses. And if we think about the typical rack, it consists of servers, PDUs, interface and power connections, IP prefixes and addresses. And if this would be creating like this kind of a rack in a NetBox via the GUI, it would be more than 400 operations. So it would be quite time-consuming, boring, and very error-prone. And I would say that this would be quite impossible to create via GUI if you need to do like 10 racks. And in our case, the only option is to create this documentation with the code. And it's very important for us to make it right, as the rest of the automation pipelines depend on this information. For example, that the cabling information has to be right. And we have a lot of history behind us. So we have been, NESC has been there since 2010. So we have a multi-vendor environment, we have multiple device types, multiple rack layouts, and multiple different cabling layouts. And there are also different type of racks. So for example, compute, storage, and GPU racks, they are completely different to each other. And we started tackling this issue by creating templates for the data models for the racks. So first we have the one template that defines the rack layout. So what kind of devices do we have in the rack and their in the positions in the rack, and we have another template for defining the cabling between the devices, and then one more template to which basically defines how the IP addresses are allocated to the devices. And we use NetBox feature custom scripts for creating these racks. So for those who are not familiar with the custom scripts, that's a feature that allows running your own Python code on the as part of NetBox application. And we selected custom scripts over the REST API because then we get this nice UI in the NetBox app, and these scripts are run on the part of NetBox app, so they work way faster than integration of the REST API. And also this supports transactions. So for example, if there would be a situation that the script for some reason fails, all the changes are reverted back. So if we would do this over the REST API and let's say the connections between the client and the server would fail, you'd end up having like a half-baked rack, and it might be quite complex to continue from there. And basically this kind of a template is that the user who creates the rack has to fill in the information, and then the script runs. And here's the example of the rack creation template, which basically defines that the dimensions of the rack, the devices which are in the rack and their positions, and the two other templates for power connections and the interface connections. And we also add the PDUs as non-rack devices. They just don't have the U location for the rack. And the cabling template looks like this. So this one is a CSV file, and each of the line basically represents one cable in the rack. So there's and the devices are identified based on the U location. And we have a similar CSV file for defining the power connections. And one more script for creating the IP addressing. So we need to select the rack and the template, which basically defines that the logic for allocating the IP addresses. And this one is another YAML file. So how this logic works is that we first allocate the prefix. So for example, in this case, we select that based on the prefix role and the tenant, and then we allocate /26 block from that parent prefix. And then we allocate the IP addresses from that allocated prefix. And the allocation is done in this case based on the U location in the rack. So this is a bit simplified example from what we have in production, but the logic is basically the same. And in this case, I'll show you the demo part. Okay. So this is the NetBox UI. And I have selected here as other and script. And this is, maybe I can make it a bit larger. So first we need to select the template. So this is basically just a drop-down menu. There could be multiple. We actually have more templates. This is just a demo instance, what I'm running here. We select the site, we select the location within the site, and we keep the name suffix for the rack. We also add some information to the rack, like the asset tag and purchase order, and then we document how the power should be connected. And as I mentioned, that this supports transactions, so it's possible to run the scripts as a dry run, so that if, for example, there would be some overlapping names or stuff like that, this would then fail. And this is running on my dev instance, so the running of this script is probably a bit more than 1 minute. But now when this should go a bit faster when this is not actually writing anything to the database in this case. Okay, so there wasn't any issue, so we can just run this one. And the rack name should be found with the T22 once this script is run. Do you have any questions so far while we wait the script to run? Okay, go ahead.
What is running? That's what I was looking for. What is happening here in the background? Like, why is it taking so long?
So basically, there's it creates the rack. It creates all the devices into the rack, and the lowest part is actually connecting the cables. So I'll show it to you once it's running.
Oh, okay, cool.
Yeah. And this is not our production setup. This is running on the Docker Compose, so it's not any kind of production trade system. So now we should be able to find it with the 322, and now the rack is here. And we can see that the devices have been populated to the rack, and then we can see that from the interface's point of view, we can see that that all the cables have been created to the full rack. And I can then show you the next step, which would be the assigning the IP addresses. So now we need to select basically the same rack that we created. Just T22, and in this case we have only single IP allocation template here, and let's just commit the changes. Okay, so now we can see what was done here. So it allocated a prefix for the rack, and then allocated the IP address for the OOP access. So 322. Let's go again here, and we can find the rack here, and we can just pick up one of these devices here, and we can see that the IP address was allocated for here. And we can see that this is the prefix that was allocated for the rack, and then we can see all the IP addresses that was allocated for the rack. Okay, that's all.
Thank you. Any more questions? Great. Thank you again.
Okay, thank you.